Welcome you all to this lecture. Here we will be discussing some important points from differential equation. So basically differential equation it is there in our first module, and here we will be starting from the initial value problem. So what is initial value problem? See, a problem already you know that dy dx, it represents the first order derivative of y with respect to x. If this is equal to f of x comma y, where f of x y it is function of x and y. Okay, so in this case what you have, see, in this case this setup, that is dy dx is equals to fxy, this along with one condition that y at x0 it is given as suppose y0. Okay, this setup it is known as initial value problem. See, initial value, why we are saying initial value problem? That means the y value at some initial point or initial input it is prescribed as y naught. Okay, so this setup it is initial value problem. So from here, see, when you solve this first equation, then you will be getting general solution. Okay, and when you apply this condition, that is the initial condition, if you apply, so you will be getting particular solution. Okay, so this is the idea. So now we are moving to question where we'll be solving. For example, you can take one question, that is here this question. See, this question this is one example. So where this dy dx is equals to this one given with some condition y0 at 1 it is given. Okay, so that means basically you are going to find a particular solution. So there are few methods by which one can find the solution. So we'll see those methods one by one. First method, it is separable variable technique. Okay, separable variable technique. So this method says that suppose you have this type of setup, that is f of y dy is equals to phi of x dx. That means all the term consisting of y are in the suppose left hand, and the other terms which consist of x, they are in the right hand side. Okay, so in that case this separable variable technique you can directly apply. That means separable variable means you are basically separating the variables, and after that immediately by doing some integration you will get the answer. So the solution it is given by this. That means if you have this setup, so immediately in the next step, integral f of y dy is equals to integral phi of x dx plus c will give you the answer. So if it is this form, okay, or the equation can be arranged in this form, so immediately this integration will give you the answer. For example, this is a classical question. See, dy dx is equals to e power 3x minus 2y plus x square e power minus 2y. This one you need to solve. So how we'll do that? See, dy dx solution I'm doing here. Okay, dy dx is equals to, see, as a whole from here you can take e power minus 2y common. Okay, so here you will have e power 3x plus x square. So now see, separable variable, this form you can obtain this form from here. See how this e power minus 2y you can take here in the left hand side, so it will look like this. E power 2y dy is equals to e power 3x plus x square. Here you can take dx. Now see, this is nothing but exactly this form. Okay, exactly this form. So now you can immediately do the integration where c is a constant, arbitrary constant. So your answer would be e power 2y by 2. Here do the integration, 3x by 3, here x cube by 3 plus c. Okay, so this is your final answer where arbitrary constant is c. So you can further simplify and you will get this expression. It is not mandatory that you need to get this last expression. You can keep up to this, no problem. Okay, so this is one simple example of separable variable technique. Now see, next question is this one. So here again, say dy by 1 plus y square you can take, here dx by 1 plus x square. you have that form, and immediately this integration you will do plus c. So here if you do the integration, what you will get, see here, from here you will be getting tan inverse, you will be getting tan inverse here, see tan inverse y, here tan inverse x plus c you can take. Okay, tan inverse y is equals to tan inverse x plus c. You can keep up to this, no problem. Otherwise, if you want this simplified form, so in that case what you will do, tan inverse y minus tan inverse x is equals to c. Now here tan inverse a minus tan inverse b formula you can apply. So immediately what you will get, y minus x by 1 plus xy tan inverse. Okay, you'll be getting this one is equals to c. Then tan c, that is y minus x is equals to what you will get, tan c 1 plus xy. Okay, so tan c, this one you can rename as a new constant, that is y minus x is equals to a times 1 plus xy, where a is tan c. Okay, so this is not mandatory to get this last form or simplified form, you can keep up to this, not an issue. Okay, so this is how we solve the questions by using separable variable technique. So if you have any doubt or query, you can ask your question in the comment section. Now see that question what I just told you, that one initial value problem. See this question, dy dx, this third question, dy dx is equals to 4x plus y plus 1 whole square if y0 is equals to 1, it is given. Okay, so basically they are asking to find a particular solution, this is the question. Okay, so dy dx is equals to this one. So in this type of question, see directly you cannot apply separable variable technique. So what you need to do, you need to do one substitution first. See 4x plus y plus 1, I am doing the solution from here, is equals to, suppose z you can take. See your target is to get here dy dx. All right, so basically we are going to do the derivative with respect to x here. So 4 plus dy dx is equals to dz dx. So from here dy dx, this can be written as dz dx minus 4. Now you can substitute this quantity here in this equation. So after substitution, what you will get, dz dx minus 4, that is equal with z square. See this term we have taken as z. So here instead of this we are going to put z square. So from here what you will get, dz dx is equals to z square plus 4. Now if you further do the separable variable, now you can apply separable variable. See dz by z square plus 4 and dx. So all the term consisting of z, it is one side, another side you have only term of x. Okay, so now you can do the integration. So dz z square plus 4 dx. So here you have 1 by 2 tan inverse z by 2 is equals to x plus c. Okay, so 1 by 2 tan inverse, z means what you have, z means 4x plus y plus 1 by 2, that is equal with x plus c. Suppose this is equation number 1. Okay, because here we have very little space, so I'll be going to the next slide continuing this part. Okay, now see y0 is equals to 1 you need to put. That means what it represent, it represent at x equals to 0, y equals to 1. This is the condition you need to apply. Okay, so once you apply this condition, what you will get, see once you apply that condition, so you will be getting half tan inverse 0 plus 1 plus 1 by 2 is equals to what, here you had I think x plus c. Yes, x plus c. So basically x equals to 0 plus c. So from here you will be getting c is equals to half tan inverse 1. So basically half into pi by 4, that is pi by 8 you will be getting. Okay, so c value you are getting as pi by 8. Now back substitute there. So from 1 you are getting half tan inverse 4x plus y plus 1 by 2 is equals to x plus pi by 8. Okay, so this is the final answer or particular solution. You can write this one, or if you want further simplification, you can multiply both side by 2, and after that take this tan inverse here in the right hand side, and immediately the form you will be getting is this last form. See this last form. So what you have, see, this is the last form you can get. Okay, or you can keep this last line as it is. Okay, not an issue. Now next thing is what, up to this what we learned the basic of for example differential equation and the separable variable technique. Few questions we have solved. Now linear differential equation, what is linear differential equation, and relevant application also we have. So gradually we'll see those applications as well. Now see, when we say linear differential equation, immediately another term comes, that is non-linearity. So when an equation is said to be linear or non-linear, so this is the question. Okay, so for that just go back to the previous slides. So here one term you will get, see, an equation, see this definition, a differential equation is said to be linear if every dependent variable and its derivative involves occur to the first degree only. That means y dy dx, d2y dx2, all this term they should occur with degree 1, that is power should be 1. Square or cube, if these things are present, immediately it becomes a non-linear equation. Okay, see, products of derivative or the derivatives, the dependent variables, okay, product, that means y dy dx, this type of term it should not be present. Okay, do not occur. A differential equation is non-linear if it fails to be linear. So basically these product terms it should not be there, and higher degree terms this should not be there. Okay, but somehow we have one standard form of linear differential equation. So see this linear differential equation, the standard form. So see, dy dx is equals to px into y is equals to qx. This is linear differential equation where px and qx, these are function of x. So this form it is said to be linear differential equation. So point to be remember here that dy dx, the coefficient it is 1 here. Okay, if the equation it is not given in this form, somehow one can convert it into this form. Some equations are there, we'll see gradually. Those equation you can convert into this form if it is not given in this standard form. Okay, now to solve this equation, one factor it is required, that is known as integrating factor. That means if you multiply the integrating factor with this equation, so immediately the equation is solvable. Okay, so integrating factor, the formula you should remember, that is e power integration px dx. Okay, this is integrating factor. So if you want the proof how we are getting this integrating factor, so all these proofs or whatever the result we are using, behind the result what are the theory involved, those things you can go back to the considered textbook, you will find there. Okay, in the Google Drive also I will share the link so that you can directly go and check the references there. Okay, if you are interested for the proof. Now see integrating factor, once you have the integrating factor, so immediately the solution it is given by this term. See, y into the integrating factor is equals to integral qx into integrating factor dx plus c. Okay, so this is the integrating factor, and while having the integrating factor, and this is the general solution. Okay, so now applying this formula will solve few questions. Okay, so for example we can take this initial problem. See, this is not given in this problem, it is not given this form, dy dx plus pxy is equals to qx. This is not given in this form, but we can make it into this form by just dividing this entire equation by x plus 1. So what we'll get, see, Immediately in the next step, dy dx minus y by x plus 1 e power 3x, here x plus 1. So if you compare this equation, with the standard form, so immediately px is what? Minus 1 by x plus 1, and qx is what? E power 3x x plus 1. Okay, so integrating factor, what is integrating factor? E power integration px dx. So here e power integration px means x plus 1 dx. Now e power minus integral dx by x plus 1. So as per the integration formula, what you will be getting? See, e power, so here e power minus log x plus 1. Okay, so basically this is nothing but e power log x plus 1 inverse. So you will be getting x plus 1 inverse, that is basically 1 by x plus 1. Now see, integrating factor you got. Now what will be that solution? See, the solution it is given by y. The solution is given by y into the integrating factor integral q. What is q? Q is this term. Okay, e power 3x x plus 1 multiplied with the integrating factor dx. Okay, so here y by x plus 1, here e power 3x dx. You can write c as well, c. So from here y by x plus 1 e power 3x by 3 plus c. This is the final answer or general solution. This is the general solution. Okay. So process it is quite simple. If it is not given in the standard form, convert into this form, then decide what is your p and q, then find integrating factor and apply this formula. Okay. So now see another question here, and solve the initial value problem, this one with this. Okay, so first thing, from this equation you can decide what is your p and q. So px it is tan x and qx it is sine 2x. Okay, so immediately integrating factor you will be getting as e power integral tan x dx. Okay, so here e power this integral of tan x log of sec x. Okay, so here you will be getting sec x. So the solution it is given by basically general solution y into sec x, and here q is sine 2x, so sine 2x sec x dx. So if you further simplify this, 2 times sine x cos x sec x dx. Cos and sec 1, so 2 sine x dx plus c. You can write this c as well. So here what you have, minus 2 cos x plus c y sec x. Now apply this initial condition. So y is equals to 1 when x equals to 0. So these two values you need to put. So 1 into sec 0 minus 2 cos 0 plus c. So sec 0 1, cos 0 1. So basically c is equals to 3. Now back substitute here. So the particular solution will be given by y sec x 3 minus 2 cos x. Y sec x 3 minus 2 cos x. This you can keep, or you can further simplify like this. Sec x can be written as 1 by cos x. So you will be getting y is equals to 3 cos x minus 2 cos square x. This will be the final answer. So you can follow the solution. So the final answer is this one. Okay. So this type of question you should practice. Another question here I have taken, so you can consider this one as homework question as well. Say e power this one, e power minus 2 root over x by root over x minus y by root over x dx dy is equals to 1. So this is one question. So here just observe this question. See e power minus 2, this one. So e power minus 2 root over x by root over x minus y by root over x. This can be written as dy dx, correct? Dy dx. So immediately in the next step, see, in the next step what you can write, dy dx plus y by root over x is equals to e power minus 2 root over x by root over x. This thing you can do, correct? So from here you can observe this is in the standard form. This is in the standard form, correct? So where p value it is 1 by root over x and q value it is e power 2 root over x by root over x. So immediately you can find integrating factor. So integrating factor it is given by e power p. So e power dx by root over x. So e power, this is x power minus half dx, correct? So this is nothing but e power, see here, x power half by half. Okay, so basically what you are getting, e power 2 root over x. This thing you are getting, e power 2 root over x. So the general solution is given by y into e power 2 root over x. Here q means e power minus 2 root over x by root over x multiplied with the integrating factor dx plus c. So here you will be getting, say, integral e power minus 2 root over x, e power plus 2 root over x. So ultimately you will be getting only dx by root over x plus c. So this is nothing but x power minus half dx plus c. So from here what you will get, x power half by half plus c. So from here if you further simplify, you will be getting y is equals to e power minus 2 root over x, here 2x 2 root over x plus c. This will be the final solution. Okay. So this will be the final solution. So you can check this one, and this type of questions are very important. If directly given in terms of linear form, that is okay, otherwise you have to convert into the linear form. Okay, now see the next one, it is exact differential equation. So exact differential equation, it states that suppose one equation is there, that is m dx plus n dy is equals to 0. If equation it is given in terms of m dx plus n dy is equals to 0, and as a whole this entire term if you can express like this du, one differential term, then this is exact. Okay, that means directly you can do integration and you will get the answer. So every time converting into this du, it is not very easy. This method, it is known as method of inspection as well, where you can directly convert this entire expression in terms of a single differential form, and immediately in the next step you will do the integration. But it is not convenient every time. It is not very convenient to approach like this. Okay, so better there is one condition, that is known as this condition. See, del m del y, this condition, this del m del y is equals to del n del x, del m del y is equals to del n del x. If you are able to get this, immediately you will say this is exact differential equation, and the solution it is given by solution it is given by, it is there already in this slide. Next slide, go to the next slide. See, solution it is given by integral m dx plus integral term of n not containing x dy is equals to c. So while doing integration m dx, you should take y as constant. Okay, and here in the second term, second integral, term of n not containing x, that means only those terms you should write here which consisting of y only. Okay, so now see one question here. One question we can take, for example, this question we can take. See this question. Solve this one. Solve this question. Okay, so here this is m, this is n, this is m and n. Now if you do if you do del m del y and del n del x, so del m del y for this first term, if you do with respect to y, so this part will contribute 0, and here you need to apply the product rule. So basically you will be getting 2y e power x y square plus y square as it is, then partial derivative of this e power x y square. Here chain rule you can apply, so you will be getting 2xy cube e power xy square. You can verify this, and del n del x, if you do here, this second part will give you 0, and the first part del n del x, first part, again the product rule you need to apply, 2y e power xy square plus 2xy cube e power xy square. So basically both are same, means this equation it is exact. So the solution it is given by integral m dx, where y is constant, e power x y square plus 4x cube dx plus here term in n not containing x, means minus 3y square dy is equals to c. Now you can do the integration and you will be getting this as the answer. Y square e power xy square by y square plus 4x power 4 by 4 minus 3y cube by 3 is equals to c. So the final form it should be e power xy square x power 4 minus y cube is equals to c. So this is the final answer. Likewise you can solve the questions. So in the exam, if the process it is not mentioned, you first need to check whether that equation is linear standard form or not. If yes, then go for the solution. Otherwise next you need to check whether it is exact or not. If exact, then you can apply this method and get the solution. So likewise you need to solve these questions. And here another problem I have stated, so you can write down this question and try to solve this, that is this question, okay, m dx n dy, okay, m and here you have n. So m del y you need to find, del n del x you need to find. You will see both are same. So immediately in the next step you will do the integration here with respect to this dx, and here integration not containing x. So basically here in this term, this term not containing x, means all the terms are consisting of x only. Okay, so here what you will get here, basically on the first term this one, next term here 0 dy is equals to c. Now in the first term, see, you should take y as constant. So if you take y as constant, you will be getting this term from the first part, and from this part you will be getting this one. Okay, is equals to c. Quite straightforward. Now up to this, these were some basic idea of this first module, where we have the differential equation of linear type. Now we have some application. So first application we'll see according to this Newton's law of cooling. See Newton's law of cooling, what it states, that rate of change of the temperature it is directly proportional to the difference between the temperature of the body and temperature of the surrounding, that is d theta dt. It is rate of change. It is proportional to theta minus theta 0. Okay, this rate of change. Okay, and here this, because the temperature it is decreasing. Okay, Newton's law of cooling, it is the body, it is getting cool down. Now see what you have, d theta dt, this is the rate of change which is getting decreased, so that's why here you have minus. Okay, and k is the proportional constant. Okay, so basically you have d theta dt is equals to minus k theta minus theta 0, where theta 0 is the temperature of the surrounding and theta is the temperature of the body at the time t. Okay, so basically d theta dt is equals to minus k theta minus theta 0. This is Newton's law of cooling, and you can observe this equation. This equation, it is nothing but a linear equation of first order. Okay, and solution also, immediately you can do the solution. One question based on this Newton's law of cooling example. See what it states. It states that a body originally at 80 degree centigrade and cools down to 60 degree. Basically it is the cooling process you are having in 20 minutes. The temperature of the air being 40 degree centigrade, means the surrounding temperature, that is theta 0, it is given as 40. Okay, what will be the temperature of the body after 40 minutes from the original? Okay, so this is the question. So basically d theta dt, it is going to be minus k theta minus 40 theta 0. This is the equation you are having. Now from this equation you need to find a theta, expression for theta, and finally at t is equals to 40 you need to find theta value. This is the question. Okay, so solution, I'm going to the solution in the next slide, it is there. So here you can see solution. Here see the solution. D theta dt, it is minus k into theta minus 40. So immediately separable variable you can apply. So separable variable means here d theta by theta minus 40, that is going to be minus k times dt. Now you can apply integration here, so you'll be getting log theta minus 40 here minus kt plus some constant it is there. As per your convenience you can take the constants form. Okay, so here we can take log c. Why? This, in this case the calculation will be a little easier. Otherwise you can take simply c also, not a problem. Okay, so in that case what you will have, log theta minus 40 by c is equals to minus kt. So from here what you will get, theta minus 40 by c is equals to e power minus kt. So further simplification will give you theta is equals to 40 plus c e power minus kt. This is the form we are having here. See, okay, so these are the intermediate steps you need to do in the exam. Okay, and while practicing as well. Now see, once you have this expression for theta, here what are the unknowns? You have c and k, these are the unknowns. So for that, two conditions are already given, so we'll apply those two conditions and we'll get the values of c and k. So what are the conditions given? See, at initially the body it is at 80 degree. Okay, so theta is equals to 80 when t is equals to 0. You can apply that, as well as you can apply t is equals to 20 when theta is equals to 60, means it at time 20 and the temperature it is 60 degree. So you can apply both and ultimately you will get the value of c as well as k. So how we will get that? See the expression, you just see that expression. What is that? Theta is equals to 40 plus c times, theta is equals to 40 plus c times e power minus kt. I think this one, yes. Now see, you can apply t is equals to 0, t is equals to 0 and theta is equals to 80 first. So here 80, 40, c e power minus k into 0. So from here c is equals to 40, you are getting c is equals to 40. Okay, and from the next condition, that is you want to put t is equals to 20 and theta is equals to 60. So if you want to put here, so what you get, 60, here what you have, 40 plus c times e power minus kt minus k into t, so 20 into k basically you have. So here c value already you got 40, so 60 minus 40 is equals to c is equals to 40, you got e power minus 20k. So from here you will be getting 2, 20, here 40, so e power 20k, that is 2. So from here you take logarithm both side, ultimately you will get 1 by 20 log 2 as the k value. So this value is here. Okay, so these intermediate steps you need to do. Ultimately if you plug all these things in the main expression of theta, you will be getting this one as the value for theta. Now at t is equals to 40 minutes they are asking, so you just plug t is equals to 40 here. So here is the calculation for you. So ultimately 50 degree will be the answer. So Newton's law of cooling, it is one of the direct application of differential equation of first order. Okay, and similarly you have many questions, you can try those. So similar type of question it is here for you. So example, these examples you can try, these examples. Now next application it is, see, Kirchhoff's law. You already know that in the physics you have the idea of Kirchhoff's law. So for that the basic relations you have I, then voltage drop across the resistance, inductance and capacitance. So all these terms you have now. You know that Kirchhoff's law for a closed or for a circuit, closed circuit, what you have, the algebraic sum of the voltage drop around any closed circuit, that is equal with the resultant electromotive force in that circuit. So Kirchhoff's law, it directly leads to one differential equation of first order and linear type. So see, voltage drop here for a closed circuit, suppose for a closed circuit, here see the voltage drop, it is sum of the voltage drop, it is equal with the electromotive force for the entire circuit. So which is nothing but this one. From physics already you have this formula. So if you just write this formula properly, then it leads to this one, which is nothing but the standard form of first order linear differential equation. Okay, di dt plus r by li e by l, so which is nothing but in the form of the linear differential equation. So immediately integrating factor you can find this one, and by applying that formula you will get the expression for I as well. Okay, so this is another example. Now see this one question here. Example, a 12-volt battery is connected to a series circuit in which the inductance is half Henry and the resistance is 10 ohm. Determine the circuit and determine the current I if the initial current is 0. So this is the condition given. Okay, this is the condition given. So di dt is equals to, see, go back to the main formula. Di dt plus r by l into I e by l. Okay, see, consider this one. Consider a circuit containing resistance R ohm and inductance L Henry. Okay, so resistance R ohm it is given, okay, and inductance L Henry it is given, okay, with a voltage source battery E, with a voltage source battery E. Then immediately you have this equation. Okay, so this thing you need to remember: di dt plus R by L I is equals to E by L, where R is the resistance R ohm and inductance L Henry, and E is the voltage source. Okay, now see voltage here, what you have, see, yes. So for this question, if you apply that formula di dt plus, see what you had earlier, R by L. See, R by L, what is R here given in this question? What is R given? R is 10, so 10 by inductance is half, so half I. E is what? E is equals to 12 by half, so that will give you this expression. Okay, this again linear differential equation, so integrating factor you can find e power integration p dx, here p dt, so 20 dt integration. You get this one. Now the solution it is given by, that is integrating factor is equals to e power 20 dt, that is e power 20 t. Solution it is given by I times e power 20 t integral, what is here, 24 e power 20 t dt. So if you do this, so I e power 20 t, 24 by 20 e power 20 t plus c, this one. Okay, so here I is equals to here 6 by 5 c e power minus 20 t. So this is the general solution. Now the initial condition I0 at t equals to 0, I is equals to 0, so t0 I0 if you put, you'd get c is equals to minus 6 by 5, back substitute here and you will get the required value for I. Okay, so this is one of the application, and this type of questions are also important for exam. So basically in this type of question, this formula you should remember, along with what are the representative for R, L and E, those ideas should be clear. Okay, now in physics already you have studied these things. Similar type of questions are listed here, you can try. Now another question, you can try those questions. Radioactive decay. Yes, Rutherford showed that the radioactive decay of a material, it is directly proportional to the amount of material present. See, this is the decay equation you have. So du dt, it is directly proportional to u. So basically it is decay, means something it is getting destroyed, so radioactive decay. So minus du dt, it is directly proportional to u. Okay, so from here you will be getting this equation. Again you can find the solution like this: u is equals to e power c into e power minus kt. Now put t equals to 0, there will be some initial value for u, and from there you will be getting this one. Okay, so that is the idea. Now next is what? Half time. Okay, half life period. So this term you should also know, that is at t is equals to, suppose at t equals to capital T, u value, it is half of the initial value. Okay, that means u is equals to u naught by half, u naught by 2. Okay, so if you apply this one here, what you will get? u0 by 2 is equals to u0 e power minus k into capital T. So from here, see what you have: half e power minus k, e power minus k capital minus k into capital T. Okay, so from here e power k capital T is equals to log 2. So that is, if you sorry, here it is 2, so if you apply logarithm both sides, so T is equals to log 2 by small k. So that is capital value for capital T value. Okay, so that is the half-life you should know that log 2 by k. Now one question you should take here, see, from radioactive decay, the rate of decay of radioactive material is proportional to the amount present. It's already given here. The half-life period of a sample of material is 10 years. Half-life period, it is 10 years. How long does it take for 90% of the original amount of material to disintegrate? This is the question. Now again you can write down that main formula. Okay, that is du dt is equals to minus ku. Now u0 is the initial condition, so you get this one here. Now see, as per the given condition, what are the conditions given? Just see, half-life it is 10 given. Okay, how long does it take for 90% of the original amount to be disintegrate? This is the question. Half-life it is 10. So half-life 10 given means, you know that half-life, the formula log 2 by k. So that means log 2, you can directly use this result, log 2 by k, that is equal with 10. So from here k value you can find, that is 0.06931. Okay, this is the k value you have. So you back substitute here the k value, so you have this expression. Okay, now the question is 90% they want to disintegrate, 90%. So 90% disintegrate. Now that means 1 minus, so basically u0 is the initial, minus 90% disintegrate means 90 by 100 into u0. This one is the current quantity of material. Okay, so that is equal with, see here, u0 e power minus 0.06931. Suppose capital T1 time, this is the material quantity. Okay, so immediately now see here u0, both side you can take u0 common, and immediately what you will have here, here 10 by 100, that is 1 by 10, that is e power minus 0.06931 T1. So e power 0.06931 capital T1 is equals to 10. Now take logarithm both side, and after that do the calculation. You will get 33.22 years as the answer. Okay, 33.22 as the answer. You should take help of your calculator as well. So likewise we solve the question from radioactive decay. Another question, see, a colony of bacteria is grown under ideal condition in a laboratory so that the population increases exponentially with time. At the end of 3 hours there are 10,000 bacteria. At the end of 5 hours there are 40,000 bacteria. That means the population it is increasing. How many bacteria were present initially? This is the question. Okay, initially how many bacteria was present? Now see, it is not the case of decay, rather it is the case of population model, increasing, population increasing. So basically du dt is equals to k into u. This thing you need to apply. Okay, after that just go with the routine work, that is this expression you will be finding. After that, see what it is given. After 3 hours 10,000 bacteria present. So after 3, that is t is equals to 3 you need to apply, and 10,000 is the u value, and t is equals to 5, 40,000 is the u value. So both the values you can apply and you can get the value for k. Okay, value for k. So once you get the k value, immediately the initial value also you can find. Two conditions are given and two unknowns are also given. So k, once you get k value, immediately u naught value also you can find. So just go through the solution. Steps are quite clearly mentioned. You will get the idea. If still any question or query you have, you can drop your questions in the comment section. Okay, so that's it. In the next class we'll discuss few more topics from this differential equation. Okay, thank you. And if you find any helpful understanding from this video, you can share this one with your friends as well, so that many more students get benefited with these lectures. Okay, thank you.